Hello everyone, hope you are all doing good. My name is Suresh Kumar Gundala. I have around 17 plus years of experience in IT with major focus on enterprise architecture and designing distributed systems, APIs, and micro UI applications. Today I'm going to talk to you about revolutionizing healthcare with enterprise architecture and discover how enterprise architecture reshapes healthcare digital systems. During this talk, when you watch the video, please feel free to connect with me in LinkedIn. You can search for my name, Suresh Kumar Gundala, and feel free to share your questions or any discussion points, and I'll be more than happy to talk to you. I'll try to put in as much content as I can with this presentation so that you can use this knowledge in your daily software development activities and then implement the same in your full stack programming. That being said, let's jump on to the talk. Over the first slide, we'll discuss about the core components of modern healthcare infrastructure. So modern healthcare infrastructure is built on a foundation of advanced knowledge that supports seamless, secure, and efficient care delivery. Three key components define today's healthcare infrastructure are the first one being distributed systems, wherein healthcare organizations operate through interconnected networks that link multiple facilities like hospitals, clinics, labs, and specialist centers. So these distributed systems enable real-time sharing, enhance coordination among care teams, and support collaborative care models that improve patient outcomes. And the second one being the standardized APIs. So to ensure diverse healthcare applications can work together, standardized APIs, which is also called as application programming interfaces, serve as the common language between different systems. So these interfaces simply the integration of electronic health records, also called as EHRs, lab systems, pharmacy systems, and other digital health solutions. They reduce operational silos and make data exchange faster, more accurate, and more secure. And the third one is the security measures. With the growing volume of sensitive health data, robust security is essential. Modern healthcare infrastructure employs advanced security measures, including data encryption, strict access controls, and continuous system monitoring. These safeguards protect patient privacy, ensuring compliance with regulations like HIPAA and build trust between patients and providers. On the next slide, we are going to talk about blockchain's impact in healthcare. Blockchain technology is reshaping healthcare by bringing new levels of security, transparency, and efficiency to how data is managed and shared. With enhanced security, blockchain's immutable nature ensures that once patient records are created, they cannot be altered without detection. This dramatically strengthens data integrity and protects sensitive health information from tampering or unauthorized modifications. Blockchain technology also supports improved data access. So, with blockchain, authorized healthcare providers can gain real time access to accurate and complete patient histories. This immediate availability of records improves the decision making, reduces redundant testing, and supports better community care. With blockchain, we also see reduced data breaches. By using a distributed ledger, blockchain eliminates the single point of failure, making it far more difficult for cyber attacks to compromise patient data. Attackers would need to breach multiple nodes simultaneously, which is an almost impossible task, which greatly reduces the risk of large scale breaches in healthcare systems. Blockchain also enables smart contracts that automatically enforce rules and agreements, which can streamline compliance with healthcare regulations and accelerate processes like insurance claims, reducing administrative burdens, and improving the patient experience. On the next slide, we'll talk about FHIR standards and the interoperability solution. Modern healthcare relies on fast, reliable access to patient information across diverse systems. FHIR plays a critical role by enabling standardized data exchange. With FHIR, healthcare providers can access real-time patient information across different platforms, improving coordination and supporting better clinical decisions. And we'll also talk about seamless integration, where FHIR bridges the gap between legacy systems and modern healthcare applications. It allows older technologies to integrate smoothly with newer tools, creating a more connected and cohesive healthcare data environment. This integration helps reduce data silos and enhances the continuity of care across different facilities and services. We will also talk about developer-friendly framework, primarily built on RESTful API architecture. FHIR is designed to be an easy for developers to implement. Its simplicity accelerates the development of compatible solutions, helping healthcare organizations quickly adopt and scale new technologies without the heavy lift of complex integrations. All right. We will talk on the next slide. We'll talk about cloud computing, where scalability meets security. Cloud computing is transforming healthcare IT by providing flexible, secure, and cost-effective solutions that adapt to evolving clinical needs. So the first one being elastic resources. Cloud platforms allows healthcare systems to dynamically scale during periods of high demand. Computing resources automatically expand or contract based on patient volumes, ensuring consistent system performance and uninterrupted care delivery, even during unexpected surges and heavy loads. And the second one is the cost optimization. With consumption-based billing models, healthcare organizations only pay for the resources they use. This completely eliminates the need for costly upfront infrastructure investments and allow savings to be redirected towards improving patient services and advancing clinical innovation. Another aspect of cloud computing is the data protection. Patient data is safeguarded with military-grade encryption, both during transmission and while stored. Advanced access controls ensures that only authorized individuals can access sensitive critical information, reinforcing trust and maintaining compliance with healthcare regulations. Another aspect is the disaster recovery. Usually, cloud-based geographically distributed backups provide a robust disaster recovery capabilities. Like in the event of a regional outage or in the event of a natural disaster, critical healthcare operations continue seamlessly, protecting patient care and maintaining operational resilience. Over the next slide, we'll talk about the enterprise architecture implementation benefits. Implementing enterprise architecture in healthcare organizations delivers measurable improvements across key operational areas. Like, for example, the first one being there is a 37% workflow improvement. By integrating clinical systems seamlessly, enterprise architecture accelerates healthcare workflows faster and more efficient way, so that these clinical processes lead to improved patient care and reduced administrative burdens. We also see 54% enhancement in the system reliability, all because of, again, enterprise architecture frameworks, which significantly boost system uptime with major reduction in critical failures and downtime. This ensures continuous access to essential healthcare applications and data. We also observed 89% improvement in data consistency through standardized data models and governance. Enterprise architecture dramatically enhances the accuracy and consistency of information across distributed healthcare networks, thereby improving clinical decision making and reporting. So we also observed 42% cost reduction overall with streamlined operations and reduced maintenance demands. Enterprise architecture drives substantial reductions in operational expenses, allowing organizations to reallocate resources towards innovation and patient care initiatives. Over the next slide, we'll talk about user-centric interface design. Designing healthcare technology with the users in mind leads to greater satisfaction, better outcomes, and improved operational efficiency. The first one being user satisfaction. Intuitive, easy to navigate interfaces that align with established clinical workflows minimize the learning curve. This reduces training time, enhances user adoption, and boosts overall productivity in clinical environments. And the second one is cross platform compatibility. A consistent and seamless user experience across workstations, tablets, and mobile devices ensures that healthcare providers can maintain continuity of care anytime, anywhere, regardless of the device that they are using. Another aspect is accessibility. By embracing inclusive design principles, modern healthcare applications accommodate a wide range of user needs, abilities, and preferences. This commitment to accessibility promotes equity and usability across the entire healthcare ecosystem. Another one is the security integration. Security measures are thoughtfully embedded with natural workflows, ensuring strong protection of sensitive data. By integrating compliance seamlessly into everyday actions, clinical efficiency is preserved without compromising security standards. Over the next slide, we'll talk about strategic phased implementation of the enterprise architecture. The first one being the foundation, where the first phase focuses on building a robust infrastructure supported by comprehensive security frameworks. This strong foundation ensures that enterprise architecture can scale reliably while protecting sensitive healthcare data from evolving threats. And the next one is integration. A seamless integration connects previously isolated systems using standardized interfaces and interoperable protocols. Disparate platforms are unified, creating a connected ecosystem that improves data flow and care coordination. And the third one is optimization. Typically, after integration, most of the organizations focus on refining clinical workflows and enhancing system performance. Real world usage data drives continuous improvements, ensuring that technology evolves in alignment with clinical needs and operational goals. And the final phase is innovation. Most of the healthcare organizations strategically implement emerging technologies such as artificial intelligence, IoT, predictive analytics, and use of LLM models. This innovation not only fuels ongoing improvements but also strengthens competitive advantage in a rapidly healthcare landscape. On the next slide, we'll talk about some of the real world success stories. The first one being Metro Health System. Metro Health System achieved a major breakthrough in clinical efficiency by reducing data retrieval time by 68%. Clinicians now access patient records and diagnostic information almost instantly, enabling faster, more informed decision making at the point of care. As a direct result, patient satisfaction scores were up by almost 29%, which again demonstrates how technology driven improvements translate into better patient experiences and stronger trust in the healthcare system. Another success story is about rural care network. Facing the challenge of fragmented services across remote locations, rural healthcare networks seamlessly integrated 24 previously isolated clinics into a unified digital infrastructure. This strategic move cut critical patient transfer coordination time by almost 41%, ensuring faster accuracy to emergency interventions and specialty consultations. The improved connectivity has dramatically enhanced health outcomes in rural communities, closing the long standing gaps in care delivery and accessibility. Another success case we'll talk about is the research hospital group. Most of the research hospital groups have pushed the boundaries of medical advancements by facilitating frictionless, secure data sharing with research partners across multiple institutions. This collaborative environment boosted clinical trial enrollments by a significant 35% and also accelerating the pace of clinical studies and the development of innovative treatments. By eliminating traditional data silos, the group not only strengthened its research capabilities but also positioned itself at the forefront of medical breakthroughs. Over the next slide, we'll talk about some of the challenges and solutions implementing enterprise architecture frameworks. So the first one being legacy system integration. Healthcare organizations often operate with fragmented systems built on proprietary technologies, creating major interoperability challenges. The solution to this problem is being to introduce specialized middleware adapters and leverage standardized APIs to bridge the gap between legacy infrastructures and more modern healthcare platforms. This approach enables seamless communication pathways without requiring costly and disruptive system overhauls, ensuring that critical data flows smoothly across the entire ecosystem. Another challenge while implementing enterprise architecture frameworks might be with regulatory compliance. The healthcare landscape is shaped by rapidly evolving regulations such as HIPAA, GDPR, and the 21st Century Cures Act, requiring organizations to maintain constant vigilance to stay compliant. The solution to this problem is to adopt compliance as code frameworks that automate the monitoring, documentation, and enforcement of regulatory policies. By embedding compliance into the technical architecture, organizations can proactively manage risks, maintain up-to-date audit trails, and reduce the burden of manual oversight. Another implementation challenge is staff adoption. Transition to new digital healthcare platforms most of the times can disrupt clinical workflows, creating resistance among staff and slowing down the adoption rate. So the solution to this problem is to deploy role-specific incremental training programs that are embedded within day-to-day workflows. By tailoring training to specific clinical roles and offering it in manageable phases, healthcare organizations can minimize operational disruption while maximizing user engagement and long-term adoption success. On the next slide, we'll talk about the future of healthcare by using enterprise architecture. So healthcare is undergoing a transformative era with advancements in enterprise architecture, paving the way for smarter, faster, and more resilient systems. AI integration is set to revolutionize clinical decision making, empowering healthcare providers with real-time insights from complex medical data. By leveraging advanced artificial intelligence algorithms, clinical decision support systems will analyze patient histories, lab results, and imaging data to assist doctors in making accurate diagnosis. Predictive analytics will play a pivotal role in proactively identifying patient deterioration risks up to 72 hours earlier, allowing care teams to intervene before conditions escalate, improving patient outcomes and reducing emergency admissions. Another groundbreaking innovation shaping healthcare is edge computing, which is fundamentally redefining how and where data is processed. By moving critical data processing closer to patient care points, edge computing eliminates latency in time-sensitive scenarios such as telemedicine, consultations, or emergency interventions. Next generation remote monitoring devices equipped with on-device intelligence will ensure seamless operations even during connectivity disruptions. This technological leap enables faster response times and autonomous decision making at critical moments, fostering a healthcare ecosystem built on efficiency and reliability. As the industry evolves, zero trust security will become the gold standard for safeguarding sensitive patient data and healthcare networks. Traditional perimeter defense strategies are becoming obsolete in the face of increasingly sophisticated cyber threats. Instead, zero trust protocols enforce continuous verification of every access request, regardless of the source. Multi-factor authentication combined with robust encryption ensures that unauthorized access is dramatically reduced, fortifying patient confidentiality and regulatory compliance. These measures are essential as healthcare systems become more interconnected and reliant on digital platforms. Looking ahead, The integration of these innovations will usher in future where patient-centered care is more accessible, proactive, and personalized than ever before. By harnessing the power of AI, edge computing, and zero trust security, healthcare organizations can overcome traditional barriers of inefficiency and fragmentation. These technologies will not only streamline workflows but also empower providers to focus on delivering exceptional care experiences tailored to the individual needs. In conclusion, the future of healthcare is being shaped by a series of transformative technological advancements that are enhancing both the quality and efficiency of care. By integrating enterprise architecture with cutting edge solutions like AI, edge computing, and zero trust security, healthcare organizations are poised to address the industry's most pressing challenges while driving improvements in patient care, operational efficiency, and security. Seamless integration and predictive analytics are already improving clinical decision making, enabling healthcare professionals to identify risks and respond proactively. The AI driven decision support systems are revolutionizing how clinicians interpret complex medical data, while edge computing brings critical data processing closer to the patient care point, eliminating delays in urgent situations. With the rise of zero trust security frameworks, healthcare providers are enhancing their protection against cybersecurity threats, ensuring patient data remains secure even as the landscape evolves. The emphasis on user centric design and role specific training will also drive smoother transitions to digital platforms, ensuring that staff remains empowered to utilize new technologies without disrupting clinical workflows. As these innovations continue to evolve, interoperability remains key bridge legacy systems with modern solutions to create cohesive, connected healthcare environments. Through strategic phased implementation and continuous monitoring, healthcare organizations can optimize their infrastructure, reduce costs, and most importantly, improve patient outcomes. Ultimately, the combination of scalable, secure, and innovative technologies will help healthcare systems not only meet the demands of today, but also prepare for the evolving needs of tomorrow. By embracing these advancements, healthcare providers can deliver faster, safer, and more personalized care, ensuring a healthier future for all. I hope you liked the content. Please leave your feedback by connecting to me in LinkedIn. On that note, thank you for your time and attention. You all have a wonderful day. See you guys. Thank you.